Okay, back when we were looking at pre-calculus stuff, we looked at transformations of the absolute value function. And the regular absolute value function I have here graphed in black. But we dealt with a function such as f of x equals 3 times the quantity or absolute value x minus 5 minus 2. And remember that each one of these numbers gave us a characteristic. And we went through and we answered these questions first. Right? I'm going to do this in blue. And so when we look at this equation, we had to pull out this information first. And this is not vertically flipped because we don't have a minus sign out in front, so I'm going to put no. Is it vertically stretched or compressed? It's definitely stretched, and that's this 3. Okay, so it's factor of 3. And then we had it's horizontally shifted, right? With this minus 5 in here told us that it's 5 to the right. And then is it vertically shifted? Yes, right, because we have that minus 2. So this is down 2. Okay, and that's what you see over here with this red graph, right? It's not vertically flipped, but it's definitely stretched vertically, right? Because it used to have a slope of 1 here, it now has a slope of 3. That's the vertical stretch. The absolute value, it's an absolute value function, so that vertical stretch is the slope. It is shifted to the right 5. And down 2. Alright, now let's take a look at a trig function, right? And let's do an analogy here. Okay, so here I just tried to keep it simple, and we looked at sine of x, right? And that's this black graph, right? It's centered around 0. And now I subtracted 2 from it at the end. And the characteristics are exactly the same in terms of transformation. So is this thing vertically flipped? No, I don't have a minus sign out in front. Is it vertically stretched or compressed? No, because I don't have a number here. Now is it vertically shifted? Yeah, it's shifted down 2. Okay, and you'll see here this red graph is exactly the same shape as the black graph, which is your default sine graph, and it's shifted down 2. So now we no longer call the vertical shift a vertical shift. What we do is we call it a midline. Okay? The midline basically is the equation of the line that is halfway between the maximum and minimum heights. So if you look here at just our default y equals sine of x, right? The midline is y equals 0. Right, because it's not shifted at all. Okay, and the line y equals 0 is halfway between the maximum and the minimum. If you take a look at this red graph here, right, when we're looking at y equals sine of x minus 2, notice that everything is shifted down 2, but the midline is right here, right? It's halfway between the max and the min, and that is y equals negative 2. Okay, so that's my midline. So now instead of talking about vertical shift, we talk about midlines. Same idea, different name. Alright, now let's take a look at a different function, and that's y equals 3 sine x. Okay, is this thing vertically flipped? No, right, because we don't have a minus sign out in front. Is it vertically stretched or compressed? Yes, it's vertically stretched by a factor of 3. And then is it vertically shifted? No, because I don't have a number at the end. Okay, and so if you take a look here again in black, that's the default sine wave, and then the red one is y equals 3 sine x, right? And so here it's actually a lot easier to distinguish between a vertical and a horizontal stretch, because if you notice, the zeros are the same, right? It's just that this red graph definitely looks like it has been pulled in the vertical direction. Okay, and of course we have a new name for that, and that is amplitude. And what the amplitude is, it's the distance between the midline and the max, or the midline and the min. So our midline is here, y equals 0, right, because we're not vertically shifted. And the distance, this distance here, that's the amplitude. Okay, and so the amplitude is a non-signed number. It's an absolute value. It's always positive. Okay, You could think of it as the distance between the midline and the max, or the midline and the min. Either way, it's a distance of 3. That's what that number 3 in terms of vertical stretch is referring to. So that's amplitude. Okay, and of course we have to talk about the vertical flip, and that is this minus sign out in front. And yes, it's vertically flipped. We don't have a number, so it's not vertically stretched or compressed, and it's not vertically shifted. And the vertical flip is exactly the same as before. Okay, so the black graph is your default sine graph, and then the red line, the red graph, is just flipped upside down, right? And that is your vertical flip. Alright, so let's put it all together. So we're no longer going to use the terminology of vertical stretch or compression and vertical shift. We're going to talk about it using our trigonometric vocabulary. And so let's look at the function f of x equals -3 sine x minus 2. And is this thing vertically flipped? Yes, right? Because we have that -3. And our amplitude is 3. It's that 3. And the period, we always talk about period. That's 360 degrees by default. We haven't changed that at all. We'll talk about that in class. And then the midline is y equals -2. So here's what I do. I'm going to actually run out of space on this graph because I didn't really plan well, but oh well, you'll see. So I'm going to start with my midline. And this line really doesn't exist. I'm just going to draw it in here just as a reference. That's y equals -2. And then what I do is I do my amplitude. Okay, so I know that sine starts at the midline, and then at 90 degrees it goes to the max, and so my amplitude is 3. So that means that I have to go up 3 from my midline, and then back at 180 I'm at my midline again, and then at 270 I go down 3, right? So that's what I meant by I'm off the graph. And then when I'm at 360 degrees, I'm back at the midline. And so that is the graph of f of x equals -3 sine x minus 2. Alright, and so now you have a homework problem. So in your homework assignment at the end, please put homework video problem number 1. And you're going to apply what you just learned. And you're going to deal with the function f of x equals 4 sine x plus 1. And I'd like you to write out these 4 pieces of information here. Is it vertically flipped? What's the amplitude? What's the period? That's 360. We haven't changed that. And then what's the midline? And then graph it. Okay, I will post a link to where you can download these grids. Alright, so please turn that in with your homework. Do it the next class.